Welcome back to Arxflix. Today, we're diving into an innovative new paper titled GaussianEditor, Editing 3D Gaussians Delicately with Text Instructions. This research introduces a novel framework, GaussianEditor, which aims to delicately edit 3D scenes based on text instructions. Unlike existing diffusion models, GaussianEditor uses 3D Gaussians to achieve fine-grained, localized edits. Here's a look at the GaussianEditor framework. It offers precise control over editing regions by leveraging the explicit properties of 3D Gaussians. Let's break down the main aspects of this paper. Creating high-quality 3D assets is essential in various applications such as movies, games, Arkansas, and VR. Traditional pipelines for 3D asset creation are often expensive and time-consuming. Editing pre-existing scenes using neural radiance fields has been promising, but comes with challenges in precision and localization. Existing methods like instruct-nerf-to-nerf edit 3D scenes using 2D diffusion models, which often result in global changes to the scene. This lack of precise control is what GaussianEditor aims to address. Inspired by the recent breakthroughs in 3D Gaussian splatting, this framework provides a systematic approach to achieve delicate, localized edits. GaussianEditor stands out by using 3D Gaussians for representation and editing. This allows for precise and efficient editing of specific regions within a scene. The framework comprises three main steps: extracting regions of interest, ROI, from text instructions, aligning these rows with 3D Gaussians, and delicately editing the regions within the Gaussian ROI. The first step involves the extraction of the region of interest, ROI, from text instructions. This process utilizes a multimodal model to generate a scene description from 3D Gaussians. The description is then combined with the text instruction using a large language model assistant to determine the areas to be edited. This equation represents the scene description generation, where mathcalc is the function generating text description mathcalc, DC, from the original 3D Gaussians mathcalc. The second step aligns the text-based ROI with the 3D Gaussian space. A grounding segmentation model converts the text ROI to an image ROI, which is then lifted to 3D Gaussians through training. Here, the function mathcal lifts the image ROI to the 3D Gaussian ROI mathcalc, incorporating additional user instructions mathcalo. The final step is the delicate editing process. Gaussian ROI constraints allow for localized editing using a 2D diffusion model. The model conditions on both the user instruction and the original image, calculating losses and performing gradient backpropagation within the Gaussian ROI. The loss function combines mathcal mathbum1 and DSSM losses to ensure fine-grained edits. This figure shows the qualitative results on outdoor scenes, highlighting the precision of GaussianEditor in editing selected regions while preserving the rest of the scene. The authors performed extensive qualitative evaluations, demonstrating GaussianEditor's ability to perform multiple rounds of editing and distinguish between different objects in complex scenes. Comparisons with instruct-nerf-to-nerf show that GaussianEditor achieves more accurate and visually pleasing results at a faster training speed. This comparison shows that GaussianEditor effectively separates foreground and background edits, maintaining higher quality in the final rendering. The authors conducted several ablation studies to validate the effectiveness of each module in GaussianEditor. They explored the impact of Gaussian ROI, text ROI, and ROI lifting on the final editing results. These ablation results highlight the importance of each component in achieving the desired precise editing. In conclusion, GaussianEditor presents a comprehensive framework for delicate 3D scene editing guided by text instructions. By leveraging the explicit properties of 3D Gaussians, the framework offers precise and efficient editing capabilities. The authors suggest future work extending GaussianEditor to dynamic scenes. Thanks for watching Arxflix. Don't forget to like, share, and subscribe for more deep dives into cutting-edge research. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.